carbonyl carbon. So this is the carbonyl carbon. Okay, it will facilitate the next step, that is the substrate nucleophile will easily attack. Okay, if it is alpha beta unsaturated carbon, it can also attack this side or this side. That is a different story. But I'm showing you that how nucleophilic catalyst it decreases the barrier of a reaction and help to accelerate the rate of the reaction. Okay, any questions? Any questions?
Sir?
No, sir.
Yeah, yeah.
Sir, in the first case, acyl ammonium catalysis,
Yeah.
the tertiary amine, won't it act like a base because it is sterically hindered by all three alkyl groups?
Okay, good questions. So I didn't tell you. Okay, it is the general things. Okay, this R group is not like trimethyl amine. Okay, trimethyl amine or triethyl amine. Triethyl amine is very common. These are R groups. Okay, so this is a special kind of, because this is a general one. I'm not going to tell a special case. Okay, with examples. You understand? This is a general one. It's the first slide, right, to teach you. So normally tertiary butyl amine acts as a base. If it is triethylamine, it will not work. This is a strong base, triethylamine. Okay,
Yes.
every lab, chemist lab. Okay, you need to use a special kind of things, that is the DABCO. This is a very common nucleophilic catalyst. Why? You can say this is a tertiary amine, right? But it's restricted. So here the cone angle is much more wider. It can act as a nucleophile. Okay, it can also act as a base, but it is more like a nucleophile if you have an electrophile is there, like ketone group is there. Okay, but if it is the triethylamine, okay, trimethylamine is volatile actually. If it's triethylamine, it will not act as a nucleophilic catalyst. This is a strong base, very common base, triethylamine. Does it make sense?
Yes, sir.
Okay, you need to use like imidazole, pyridine. But this is the pyridine. Okay, pyridine DABCO is actually the trialkyl, but this is the aromatic. Okay, so pyridine rings. Okay, so here the donating power is less compared to DABCO. You understand my point? Because this is nitrogen is sp2 hybridized.
sp2 hybridized.
Okay, this is sp3, but it's restricted. It's not like triethylamine. So the sterics here is much more compared to the DABCO because it's restricted. Okay, the cone
Yes.
angle is much more larger. Does it make sense?
Yes, sir.
Yeah. Okay. Good questions. Anything else? These are first general things. That's why I just give n 3 1. Okay. It looks like trimethylamine. If nothing is there, means it is in chemistry. This is methyl. But trimethylamine is actually volatile. It is you cannot use it. Anything else? If it's not, let's go. Okay. Okay. So another one, very important reaction. Okay, is a name reaction. It's called Bayes-Hillman reaction. Okay, so what it does, you have a ketone, or this is aldehyde. You have another one substrate. Okay, and you have a DABCO. So this is a kind of you may tell this is not an aldol type of things, but it helps to give this product. So what is this? You may think about that. What is this? This is the like a allylic alcohol type of product. Okay, so this is called a coupling reactions. Okay, and it's a very specific reactions. There is the name reaction that is called Bayes-Hillman reaction. That is also catalyzed by, is very famous reaction. Okay, because these kind of compounds are important synthetic intermediates to make many pharmaceutical compounds. Okay, that's why this name reaction is very famous, and this is catalyzed by DABCO. So I'm going to tell by step that how this nucleophilic catalyst also activating the substrate. Okay, the similar way. Okay. Okay, I think let's go this reaction first. Okay, my slides, I think we have one more. Okay, so for these reactions, you remember that this is the structure of DABCO. Okay, that we showed you in the beginning. Okay, this is a tertiary amine. So let's go by step that how Dabco is catalyzing these reactions. Okay, there is nothing complications. Okay, so just before, if I forget, you make sure you practice all kind of mechanism. Okay, whatever is shown in the slide. Okay, question may also come. Okay, I'm just telling you. So I told you that how nucleophilic catalyst activate the substrate, especially the ketone molecules. Okay, if it is secondary amine, it forms the iminium ion. If it is the tertiary amine, right? So it can substitute on X, or if it is alpha beta unsaturated ketone, okay, then it also react in a little different way. So here the substrate, you can see here, this is the substrate. Oh, this is the substrate. This is the same substrate with this. Okay. So what is this? EWD this is called electron withdrawing groups, means this is the ketone. This is the substrate. Okay, there are a lot of derivatives are there. So this is the alpha beta unsaturated ketone. Okay, alpha beta unsaturated ketone. So if you add Dabco, what you will do that the Dabco will attack, you can see the arrows to the alkene and give a enolate kind of intermediate. This one. Okay, so this is the nucleophilic catalyst is activating the alpha beta unsaturated ketone and giving a enolate type of intermediate. So obviously here when the Dabco is there, when it is coordinating, then tertiary amine, it will be positively charged. Okay, it will activate the carbonyl carbon. It will make the carbonyl carbon more electrophilic. Not only for that, it will also become a good leaving groups later. Okay, so now you have ketone here, right? So this is a nucleophile. Okay, so this is the arrow you can see. So now the attack from the enolate groups to the ketone will take place. Okay, to give this intermediate. Is it clear so far?
Yes, sir.
Yeah, these are very simple, like a aldol kind of reactions or addition kind of reactions. Okay, it is very simple. Okay, nothing complicated, but you need to practice. Once this, suppose this is the intermediate number 1, intermediate number 2. Okay, one intermediate 2 is formed, then it will also rearranged. It will also rearranged. Okay, to gives this another again enolate kind of forms. You can see the another one Dabco molecule will react with it is now deprotonating the HCH bond. Okay, you can see the arrows here. Okay, in the number 2 rearrangement to give the number 3 intermediate. Once the number 3 intermediates happens form, then the simple rearrangement. Okay, so you can see the blue arrows and the DMAF, the Dabco. Okay, Dabco, DMAF, both are the similar things. So it will leave. Okay, and regenerate the catalyst. And what will be the product? Product is this. Then after the deprotonation rearrangement, you will get the product. Just do the practice. So here the bottom line is you can understand that how Dabco is catalyzing the or activating the alpha beta unsaturated ketone. Okay, so if it is a secondary amine, it can form the iminium ion. If it is the tertiary amine, it can coordinate to the alkene of the alpha beta unsaturated ketone. If it is the acyl halide or chloride, right, then we discussed about that it the Dabco also can replace the Cl bond to give the N plus, right? Okay, any questions? Yeah.
So in the so in the first step of the reaction, Dabco acts as a nucleophile, right? But in the second intermediate, it acts as a base because it deprotonates.
Yeah, right? Yeah, it is a dual role. It has a dual role. And DAPCO is a catalyst. It's not like that you have the only, okay, it is a catalytic amount, but you have multiple molecules and this is regenerating.
Yes, sir.
Okay, so yeah, so this is acting as a base. All nucleophile can act as a base in a special condition, right? Because if, okay, so this is the Lewis base, right? So if it is donating to the carbon center, if it is donating to the carbon center, then definitely it can donate the electron or bind to the H plus. There is no problem. But not all bases are not nucleophile. So nucleophilic catalyst or nucleophile should be softer in nature. It will be less sterically hindered so that it can attack to the sterically congested electrophile, and electrophile comes from the carbon center mostly. Okay, yeah, so if it is there, then we because H plus is the smaller, right? Much smaller than the C plus or any kind of electrophile, carbon based electrophile. So yeah, so the second times this is acting as a base. That's true. Okay, look
Yes.
at this cycle. If you have any doubt, I hate teaching organic mechanism in PowerPoint, but we have no other point choice. Okay, so it's okay. But I will suggest all of you. How many people are here? 12 people. Okay, please practice. Okay. Have you listened what I am telling? Practice. Okay. And yeah, question may come. Okay. So I'm giving you some hint.
So,
Yeah, tell me.
so in this, the mechanism, it's not aldehyde which we are dealing with initially. I mean, in the circles, right?
This is the aldehyde. Okay, actually, I will tell you this is the aldehyde. Okay, and okay, give me one second, pen. Yeah, so you can see this is the aldehyde. Actually, this is a general mechanism. Okay, it can be aldehyde, it can be ketone. Okay, that's why I'm giving. This is the aldehyde, or this is all depends on what is the R1 and R2. It can be
Okay,
aldehyde.
so the first attack by DAPCO is on the EWG group.
Yeah. Okay. Yeah. So which is the alpha beta unsaturated ketone. But if I ask you a questions, I will not give any vague things. What is the EWD, electron withdrawing groups? Okay, I will give the specifically a alpha beta unsaturated ketone. Do you understand my point? This is more like a general mechanism. I can give the ketone also. Suppose acetone instead of aldehyde. Okay. Look at this. Any other questions? So let me clarify here also. Okay, so in this electron withdrawing groups, okay, it is also reported that it can also act not only for ketone. Suppose you have the cyanide, it can be nitro, similar kind of things. Do you understand my point? It can be something like this instead of ketone also. Okay, and this is the ketone, so it can be anything. Same mechanism.
Sir.
Yeah.
So pyridine would also work instead of DAPCO, right? Like same way.
Pyridine can also work, but DAPCO or DMAF, there is one, the next last slide. Okay, is a D, what is called? This is called DMAF. DMAF. What is DMAF?
So nay.
Tell me, what is DMAF? This is the DMAF. So what is the full form? Dimethyl 4-dimethyl aminopyridine. Do you understand? 4-dimethyl aminopyridine. Yeah, those will also work. But thing is that this reaction will be better if the nitrogen is more donating ability. Okay, if it is a pyridine based substrate, pyridine is sp2 hybridized, so this is less nucleophilic. You understand my point?
Yes.
But this is the sp3 hybridized, so nitrogen has more ability to donate electrons. So this is much better nucleophilic catalyst. Okay, you understand my point? Yeah, but pyridine will work. Pyridine will work. Actually, one of the common also replacement of DAPCO is the DMAF. Okay, you can see why DMAF is also a good nucleophile, because you have a dimethyl amino group on the 4 structure. Okay, so it's a strong electron donating groups. So this nitrogen is a strong nucleophile.
So DMAP attacks from the sp2 nitrogen, right?
Yeah. Yes. This is the for this type of reaction. For this type of reaction.
Yeah. Yes, sir.
This is the class of Bailey-Silman reaction. Okay. If it is acyl chloride, then it will, there is no alkene. So whatever I told you in the first slide, right?
Yes.
So it will replace the Cl bond and activate the ketone. So that is a different way. So all depends on what type of substrate is there. If it is alpha beta unsaturated ketone, okay, then it will attack on the alkene, not in the ketone positions. Is it clear? Because this step, this side is the less sterically bulky. Because this is a bulky, right? This is a bulky group. Catalyst is also a bulky molecule. Okay, so it will attack or it will activate the substrate molecule in least sterically hindered position. Do you understand my point?
Yes, sir.
Okay, it cannot attack here. It cannot attack this position like here. Okay, because this is the ketone. This is not the acyl chloride. Then chlorine replace and the DMAP will coordinate here. Okay, this is, you have the ketone and you have the alkene. So these positions is much less sterically bulky, sterically hindered compared to the carbonyl carbon center. So DMAP will never attack here. No, only it will attack to the green line, green arrow. Clear? Anything other questions? So no. Okay. Anyone? No. Okay. So the last. Okay. So this is the similar, another one examples, but this is just an example I showed you. So this is the acyl ammonium catalysis that I showed you in the previously. So this is a you can see this is a esterification, okay, of acidic anhydride catalyzed by a nucleophilic catalyst. Okay, so what is this? I show this is similar kind of reactions we discussed last time also. Okay, like in the yesterday's class, acidic anhydride, it react with alcohol to give the ester. Okay, acidic anhydride. Okay, as is anhydride, as if it's CH3, R is CH3, then this is called acidic anhydride, and this is the alcohol to give the ester. This reaction is very slow, but if you add some nucleophilic catalyst, suppose DMAP or DABCO, it really accelerates the reaction a lot, many times, more than 100 times. It shorted down the reaction time. How it is happening? Why it is happening? Because the first step is the nucleophilic catalyst. Okay, it attack to the carbonyl carbon, one of the carbonyl carbon. Okay, leave here to give this product, Lewis based complexes. Okay, and now this adduct of nucleophilic catalyst increases the electrophilicity of the carbonyl carbon and it facilitates the attack of the alcohol, okay, to give the ester. So I'm doing some step jump. That is your job to fill up those steps. If I ask you the questions to draw the mechanism. Okay. Yeah, those are easy, right? Yeah. Okay, is it clear? So that's it. If you have any questions, please ask me. I'm here. So I hope I have able to tell you that how nucleophilic catalyst acts as a catalyst or increases the rate of the reaction. And this is a new type of catalyst recently discovered like 15 years before, and because of that Nobel Committee awarded Nobel Prize in 2021, just like last month in October, okay, to two people on nucleophilic asymmetric nucleophilic catalysis. Okay, asymmetric nucleophilic catalyst or an asymmetric organocatalyst. Okay, these are also called organocatalyst. What is organocatalyst? Metal catalyst is metal is there. Organocatalyst is means is the organic molecule. This is organic molecule. Like proline is an organic molecule, right? It's an organic molecule. No metal is there, and that's why called organocatalyst. And one of the Nobel laureate, David Macmillan, he introduced the term first, organocatalyst. Okay, so yeah, this is a new kind of things. So I thought, okay, we should teach. Okay, yeah. Okay. Anything else? So practice the problem set I uploaded today morning. And if you have any questions, yeah, we can come and meet again. And the key of those problem set, I will give it, practice it maybe Sunday. Today is the Friday, Sunday or Monday. Okay. And some of you emailed, I think, yeah, comparatively some of them, not many. There is 10 people asked me about some exam from home or from classrooms. Okay, so we will decide next week what to do. Okay, maybe Monday, Tuesday. Okay, so how many of you are in hostel now? Well, regardless, you are only one, so rest is in home, 12 people. Okay, so if you are not onboarded, then you are okay to give online exam. Okay, but I also don't like to have both kind of exams. Some are online, some are offline. Okay, and monitoring some things. It's not like a homogeneous things. It's a kind of heterogeneous stuff. So we'll decide on Sunday or Monday. I need to talk to Professor Sangreef and let's see what is the policy also. Okay, so what we'll do, we'll inform you. Okay, and exam is on 22nd. So yeah, all the best.